Hi, I just wanted to quickly go through the F statistic that you use to carry out a hypothesis about whether more than one coefficient is equal to zero. So that's our typical joint hypothesis that the coefficient on x1 is equal to zero and the coefficient on x2 is equal to zero. And the mechanics of evaluating the F statistic are pretty simple. So you look here on the degrees of freedom column and right here, and these numbers are the number of restrictions in your hypothesis test. So if you have 5 restrictions, that is if you have 5 coefficients and you're interested in knowing whether all 5 of them are equal to 0. If your significance level is 10%, then your critical F value would be 1.85. If your significance level is 2.21, then the if the significance level is 5%, then the critical value is 2.21. And if the significance level is 1%, the critical value is 3.0. Our typical hypothesis test usually involves two um, uh, restrictions. So x1 equals 0 and x2 equals 0 is our typical joint linear hypothesis test, especially if we're testing a polynomial, whether we have the coefficient on the x term and the x squared term are jointly equal to 0. So we can see at the 5% level, the critical value is 3. At the 1% level, the critical value is 4.6. And this is why we sometimes have sort of that rule of thumb of being around 4 in this area means, of course, you're going to reject. But here you have then the different critical levels for the different critical values for the different significance level. If F is larger than these values in the case that applies, then you would reject the null hypothesis that the 2 coefficients are equal to 0 or that the 3 coefficients are equal to 0.